worrying or like getting confused, and it also makes you just a better developer in general and increases your reputation in the community once you grow big.
Okay, so some terminologies here. Bug. So pretty much a bug is like an error or a flaw or like a fault in a piece of a program that you wrote that produces an incorrect or unexpected result. And to solve those bugs, we use something called debugging, which is the process of finding and removing the bugs from your the program that you wrote. So when you're actually coding, you're spending around 70 to 80% of your time debugging rather than just like actually writing code. Yeah. And here's an acronym. So don't repeat yourself. So you can go to the next line. So pretty much what dry means or don't repeat yourself is uh, don't write duplicate code. Saves more time and it's concise. It's efficient and reduces the chance of bugs and easy to debug. So an example is here. We are writing duplicate code and it costs more time to write the same code 5 lines. And if there are bugs you will need to fix, it's 5 time.
Okay, so next is wet, and which stands for write everything twice. So this is something you should avoid. So this is the opposite of dry code, and you're actually repeatedly writing the same code multiple times, and it produces the same result, and just makes it much harder to like read and debug, and so just try to avoid repeat yourself when writing code. So this is an example of wet code. So basically, what this code does is basically added parentheses between all the negative numbers. And as you can see, if we have three numbers, we are writing this 3 times, and this is very messy to read. And not if you have to debug, you have to fix this 3 times, which is not efficient work.
Yeah, so helper functions. So helper functions help us follow dry principles and prevent wet code. And helper functions is a simple function. Could also be complicated. That helps. And helper functions make your code easy to read by having descriptive names.
Yeah, so a help function basically just helps you prevent writing repeated code. So like you can just write it once and then use it multiple times. So here's an example of a helper function of the same example. So instead of writing the same logic 3 times, you can put it in a helper function that is more generalized because you will use it a lot of times and then just call the functions. So which will make it much easier to like read and collaborate. And also for the example, we've used Python because we assumed most of you guys could read it. We didn't choose any hard language, so let us know if you have any questions about the example code. So, and next up,
Okay, so keep it simple and I'm guessing it's okay. And then, so pretty much that acronym means keep your code as simple as possible and increases your code readability and simplifies your work to help both and your team. So especially in like an actual development environment where you're working with others, this is very simple to keep it simple. And last but not least, it's easy to debug. So it may sound harsh, but it is as a principle that we follow in our everyday life. So it's not just about writing good software. This applies everywhere pretty much.
yeah, so also in school or like your general life, when you have a task to complete, try to keep it as simple as possible. It also makes your life just much more easier.
Yeah, so this example, string concatenation, makes this code very messy to read and hard to debug. For example, if you're missing the
Concatenate,
concatenate
yeah.
operator, quotes, or brackets, it is hard to keep track and debug. And this is the exact same, but notice how using template literals or f-string in Python makes it very simple to write and easy to understand. So here's a quick fact. So f-string automatically converts your variables to string. So you don't have to wrap it in a string, unlike regular print function, which makes code more complicated to write and read.
Yeah, so if we go back, we see we have to use the at operator and just wrap in every variable that's not a string in str. So this is very messy and it's very complicated for anyone, even yourself and or others. So next up we have write comments. So are they really useless? When I bring this up, I know I'll hear a lot of opposing comments because I am sure it's not the most fun thing to do while coding. And it's actually true. I found that most developers don't like never comment their code. And but let's take a look at why you should. So in writing comments, it increases readability, so you know exactly what your code does, and because the comments can demonstrate your logic flow. Kind of like if you know what pseudocodes are, comments could basically help do that. And then every programmer codes in a different style. So if you comment your code, others could easily understand how the code works and what it does. And it also shows that you are just a general responsible team member that's considerate to others. And comments are just how developers communicate with each other. And you can also use comments as a to-do list, kind of like to keep track, or general note jotting. And you can remember yourself and other team members like what the code produces, what features finished, or what needs to be implemented. And the good thing about comment is that no matter how long you write your comments, you can have like 1,000 just comments, 1,000 lines of just comments, and it never affects your performance because they're completely ignored by the compiler or interpreters. So yeah, this is just some general comments started in different languages. So that's how you write comments in Python's hashtag for a single line and three quotation marks for a multi-line comment. And for C, C Sharp, C++, Java, and JavaScript, they all use the same kind of comment syntax, which is just double slash or a slash and a star wrapped inside of that for multi-line. And HTML looks a bit more weird, but it's just how the language works, and CSS is slash star for single line and multi-line. Or if you are using a general IDE, you can just do control slash to like comment your code. That's just a keyboard shortcut for you to help. Okay, so if anyone have any questions before we move on to the next topic, you can ask in the chat. Otherwise, we'll just continue. Okay, it looks like I'm not getting any questions, so let's proceed. So next topic is software testing. So writing tests. You might hear this term somewhere. So let's take a look at this topic. So software testing is a method of checking your software to determine if it matches the expected requirement and outcome. So how it works is you write a test script that executes your main code or your software. So it's external. It's different from your software to be like deployed. So basically, the test compares your broken down module to see if it matches the expected result, and it compares the result of different engineering approaches to deploy the passed code. Basically, your code needs to pass before moving on to the next stage. So why is that important? So basically, testing helps us identify bugs and error, and it prevents deploying a faulty piece of software because you don't want to like make others or your users use something that doesn't work. And testing could calculate the performance and it ensures the quality, just the general quality of your software. And it also increases customer satisfaction, or you can think of it as the UX, like the general experience of using the software. Like if I use a something that like an app that doesn't work, I probably won't continue use it, and my experience wouldn't be very good, or like to like leave a good rating or continue use your software. Sohail, do you want to um do the uh
Yeah.
This thing? Okay.
Yeah, so here's a real life example. So on April 26, 1994, China Airlines Airbus A300 crashed due to a software bug, and it actually killed 264 passengers. So it really shows how important like identifying bugs and errors in software programs are. And another example is on May 1996, 823 customers of a major US bank were credited with 920 million US dollars. So faulty test cases caused a bug to be deployed, which caused the customers to be credited with the money. And then lastly, in April 1999, a software bug caused $1.2 billion lost from a military satellite launch. This was also recorded to be the costliest accident from software industry. So before, you might think having bugs is not a big issue. It's just something frustrating, but no big deal. But bugs can be ranked from simply not working to a more serious level, that it may take down a business or costing lives.
Okay, so now let's take a look at different types of software testing. So the first one is functional. So it should be self-explanatory. Basically, it determines if the software is functional and produces expected results. And next is performance testing. Basically, determines the performance of a software. For example, CRUD operations, which stands for create, read, update, and delete. That's the most basic thing when you're working with database. So an example is functional. Functional testing is does the sign-in function take me to my account and my profile? So if it doesn't pass the functional test. And if it passes the functional test, we can move on to the performance testing. So for example, how long does it take the program to authenticate when there are 1,000 users signing in at the same time? And next is the maintenance testing. So after you've passed the functional and performance testing, it determines whether it will continue being top notch over a long period of time. So like when you have more users using your software, does it break your code or like continues um, working? So an example of maintenance testing is just upgrading your packages, dependencies, and like your security level. So. And next up, we have unit testing, integration testing, and system testing.
Okay, so unit test is to test individual components of your code without any interactions to dependencies. And, it can be test tiny parts of the program. So each individual parts are functional, and they can be performed anytime. So pays attention. It pays attention to the behavior of single modules. It is performed by the developer, and it's easy to identify bugs.
Okay, so
So, yeah, go ahead.
okay, okay. So integration test is basically you test a bundle of unit module, including any libraries and dependencies. So it's functional when combined together as a group. So like so you can pass two unit tests, but will it work when they're combined together? Some points about integration test is it is performed after passing all the unit tests, and it begins with a specific interface. For example, Windows, Linux, Mac, Android, iOS. Like it targets a specific interface on what platform the software runs. And on in integration testing, it pays attention to the behavior of multiple module, and this is actually performed by the entire software dev team. So you can't work on this alone. And this is much harder to identify bugs because everything is working as a whole. So to visualize what's going on, so this is a good GIF to like visualize it. So as you can see, uh, these two doesn't work together. That means that you can pass two unit tests, but zero integration test because they can't function together. So this is you shouldn't deploy software that are like this.
So the difference between system testing and integrations testing is that in integration testing, you are not compiling a software. And integration testing can also be thought of as multiple units testing together. So system testing is performed after the complication of the software as a whole.
Yeah, so
Complete.
the difference between system testing and integration testing, so they might sound really familiar with the like they all sound like bundle whole, but the difference is that for system testing you're actually compiling the software. So basically multiple integrations. So you can compile the software as if to be deployed. But on integration testing, you're not compiling your code. So basically just see if units work together. Okay, continue. Okay, so system testing basically tests the functionality, portability, the security, and performance and the feasibility to be deployed. So basically, you can think of this as you are the user that is about to use this app or software. So if you can't use it, it doesn't pass this test, and if you can, it could pass. So there are still exceptions. So to visualize this, here's a pyramid to show kind of the relationship between the three types. So on the bottom we use unit. See, so on the bottom is the unit test, and then integration system test. So the area represents the quantity. So unit test you write a lot of unit tests, so it takes up the most space, and system test is all the way up there, like so basically you might only do one or two system tests in the entire like timeline or cycle. So and also it is ranked from cost. So unit test is much easier to write because you can just do it yourself after you implemented a feature. But system testing, you need like the entire team. That means front end, back end, and also other system admins. So basically, the entire team comes together and test the entire software. So it's much cost to do, and it takes much longer, like usually days to complete. So
Yeah, and now we're going to be open to any questions, and then we'll continue with our live demo, which is our optional part. Yeah, I see it. Okay,
okay,
so
continue.
now we're going to go over some advanced software testing tools. So starting off with Selenium. So Selenium is like a framework that's available on Linux, Windows, and Mac for web application testings. Next up is Jenkins. Jenkins is for code-based testings. The GitHub is you can set up a GitHub testing service to prevent faulty code from merging with the master branch. Postman is for testing REST APIs by sending HTTP requests to verify the response code. And there are many other ones out there. And if you guys are more interested in learning about this topic and how to set up an advanced testing pipeline, we might continue this topic in the future with GitHub, since it's probably the easiest and most beginner friendly. But for now, this concludes our workshop for today. And thank you to everyone for attending. And we'll see you all next week at the same time.